Hi students, in this video we're going to look at Bernoulli distributions. Right, key things you should be able to do are use a Bernoulli random variable as a model for two outcome events, identify a context suitable for modeling Bernoulli random variables, recognize the mean p and variance p1 minus p of the Bernoulli distribution, and then use them to solve some practical problems. Right, so a Bernoulli random variable talks about events where there is only one trial and there are two possible outcomes. We call those outcomes usually 0 and 1. 0 would be the event doesn't happen, and 1 would be the event where it does happen. So key things from our definition there. So Bernoulli trial is one event, and there are two possible outcomes, success and failure, or it does happen or it doesn't, 0 and 1. The parameter, the probability, P, is the probability that the event happens, or getting a 1, for example. All right, it's a bit hard to think about what a Bernoulli distribution might be. An easy example would be flipping a coin once. You're just flipping a coin, there's two possible outcomes, heads or tails. That's considered a Bernoulli event. But let's talk about some more and see if we can identify whether or not these events are Bernoulli or otherwise. Right, we're going to survey one person and asking them whether they've had their flu vaccination or not. Okay, so how many trials are we having? We've only got the one trial. And how many possible outcomes are there? Well, the person's either had their flu vaccination or not. So there's only two possible outcomes there. Only one trial is done, so that is definitely a Bernoulli trial. Looking at this next one, determining how many AA batteries out of a pack of 12 last 40 hours or longer. All right, so as far as the number of outcomes, there are only two outcomes. Either the battery does last 40 hours or longer, or it doesn't. So only two outcomes, but the problem lies in the fact that we're testing a pack of 12. So we are doing this test of 12. We're doing multiple trials, so that means it can't be a Bernoulli trial. Selecting fruit from a bowl that contains oranges, mangoes, or lychees. Again, this one is not a Bernoulli trial either because there's more than two possible outcomes. So that one's an easy one for why it's not a Bernoulli trial. So one trial, only two possible outcomes. All right, so the mean or expected value of a Bernoulli distribution is calculated by, so expected value is our symbol, also mu for mean. It's just P. So what's our probability of the event happening? That's our mean or expected value. The variance is P times 1 minus P. Now, 1 minus P, that's just a probability of it not happening. Okay, so if P is the probability of the event happening, 1 take P is the probability of it not happening. And that means the standard deviation, which is the square root of variance, is going to be P, the square root of P 1 minus P. Remember, for probability questions, please good note, please remember that all answers are expected to be rounded to 4 decimal places. Okay, so let's do an example. So looking at some laboratory trials, it was found 89% of batteries lasted longer than 24 days in an Xbox remote control. We're going to let X be the event that the probability of a battery lasts longer than 24 days. Right, our first thing we have to do is construct ourselves a probability distribution. That's pretty straightforward. So we've just got our title, and we've got our two events listed down the bottom of our graph here. So we've got 0, the probability of our battery not lasting longer than 24 days, which is around about 11% there. And then you've also got the probability of a battery lasting longer than 24 days, which is this big 89% column here. And that's all it is for the distribution. Just easily graph our probabilities for 0 and 1. Reasonably straightforward. Determine E of X. Remember that E of X for a Bernoulli distribution is just equal to P. What's the probability of the event happening? So in this case, E of X is going to be 89%, 0.89. Variance For C, our variance formula is P1 minus P, which is 0.89 times, so remember 1 minus P is just the probability of it not happening. So if 89% chance of happening, 0.11% chance of happening. So putting that together, we get 0.89 times 0.11 equals, where's my pen gone? There we go, 0.0979, and then my standard deviation will be the square root of that, which will be 0.3129. So standard deviation is just the square root of my variance, but there's a simple Bernoulli distribution problem there. All right, so after watching this video, you should be able to use a Bernoulli random variable to model two outcome events. You should be able to pick some context suitable for using Bernoulli random variables. So a reminder of that, two possible outcomes and only one trial, and then recognize and determine the mean and variance as done with our last example, and also do some practical problems like we did in that last trial too.